Okay, so this is me again coming with some new improvements on this DOS project that I'm working on, right? So this is an operating system for 8-bit computers, specifically the Z80 processor, right? And what I've done, and I'll just cut to the chase, right? So make run, and we get this nice message telling us that the kernel has started. And here we get an actual shell this time. Well, I say actual, but it's not really that advanced, as you quickly see. So we can do something like, for example, if I just type hello, it's not going to find any executable. But if I do, for example, a cat, which I just added this program, and well, one, because I haven't passed any parameters. But if I pass a parameter, so for example, if I do cat test.text, you can see it finds the text, finds the file, and it reads it. And this is more than 512 bytes, which proves that the algorithm that tracks the FAT and reads the file works properly. And I'll show that quickly to you. But if it doesn't find the file, so if I do just ABC, it just says ABC not found. And this is capitalized because FAT16, well, actually, I'm not sure. But in any case, everything is just capitalized, every file name, every directory name. Because FAT16, again, I'm not really sure if it supports lowercase letters, but in any case, it doesn't matter. And as you can see this every time, so I can run this again. Every time I do, for example, if I do cat test.text, this is not a program inside the shell, right? So this is a separate program from the shell. And you can see that once this is done running, it returns to the shell. And the way it does this is it's kind of a trick. What it really does, it's the shell gives complete control to this program. So this program completely replaces the shell. It does what it needs to do, and then it exits back to the kernel, and then the kernel starts the shell once again. So this is actually not the same shell that ran this program, which isn't a problem now, but if I want to have persistent variables, maybe that might become a problem, but we can find ways around it because as you can see here, arguments are passed. So test.text is passed to the cat program, and there's this address here that facilitates this transfer of data for the arguments, right? And you can see it here as well. We set it up, wait a second. There we go, we set it up here. And this is where every argument is passed. And we can go in shell.c. This is the same thing, just referencing that same address. And if we go down a bit in a process line, I think. Yes, there we go. It uses string tokenize. It uses this function to tokenize the string and just pass the arguments, right? Here, I forgot to mention this. It does, well, this is not really path searching because it's only one path and it's a constant. So this is a constant path. It's going to look in this directory for all files with this extension, right? So what it does is it just appends this directory with whatever you typed at the terminal, but this is capitalized, so whatever you typed capitalized, and then it appends this executable extension, which is just .bin, but I should probably change this. It doesn't handle, wait a second, it doesn't handle binary files, but I mean, real cat doesn't handle them either. Like, let me just show you. So for example, if I do kernel.bin, it will just print a whole bunch of nothingness, but this is what the actual cat program does as well. So I guess that's expected. Well, I'm not sure if it does exactly this, because as you've seen, it doesn't return, which I'm not sure if that's supposed to happen with the real cat program. But in any case, this we need this this everything is in what's it called, in absolute directories, in absolute paths. So for example, if I type cat test.txt, this will not find the file. But if I do cat /test.txt, it will find the file, right? Because this indicates the root directory. And I think that's kind of all for now. This is my progress so far, and I'll see you next time.